Okay, so thank you everybody. So my name is Cedric Thienot. I'm a CTO of Firecell. Firecell developed and gives some 5G infrastructure for private network based on open interface. I used to work a lot in 3GPP, starting with release 13. So maybe you have implemented the things that I've done. Maybe not so well, so I'm part of the guy who does the specification. So before going into the private 5G network, so just few numbers for the market. Why private 5G network and why now? So I'm not going to go into the detail of the CBRS part, which is a US private network. I'm just going to explain a little bit of a European market. So what's going on Europe? Currently, they open the bandwidth and the frequency in Europe. So it will be possible to buy a frequency, so something like 100 megahertz in different countries. So the band would be N77 or N78. And it would be very not expensive, very cheap. So for instance, for 1.4 square miles, you just have to pay something like $7,000 or euro per year. So it's not so expensive. And it would be your own private network and your own frequency. And so you've got, currently there's a huge number and size of frequencies that will be available for the market in Europe and mainly for the manufacturing. So people are currently moving. And so there's an interest that starting in Europe on this private 5G. So just to start, so I'm going to focus on private 5G and for Industry 4.0. So where do we start? Currently, when we are going to see our customer, they already got Wi-Fi. Okay, the Wi-Fi is there. They already deploy Wi-Fi. There's something like an access point every 20 meters, and they already got an infrastructure, and they already have some use cases. So for instance, at the previous session, there's some video use cases where you can analyze what's going on. This kind of use cases already exist, and it's already deployed in using Wi-Fi. So this is where we stand. So how people are going to move, and why they are going to choose 5G, and why they are not going just to say with Wi-Fi. Currently, Wi-Fi is it's not expensive. So how you can make it move. So the first use cases is really the coverage, okay? They need outdoor coverage. So Wi-Fi is not good enough for the outdoor coverage. So this is a kind of use cases. And then also they want also to have a better signal, a better quality of service for the Wi-Fi. For instance, I know people who have been using the Wi-Fi and the video, so they've got something like 200 frames per second, and they do the analysis of the 200 frames per second and just to know what's going on. And it's working, but they don't know how many streams they can do with the Wi-Fi. So they add one, they can add another one, and suddenly they know that it will drop. So there's this kind of quality of service is not there. So this is where we are, and this is what we want to do and what we want to cover. So really what we want to have is to make 5G as easy, as affordable as Wi-Fi. No, it should be the same price. It's not going to be possible, but it should be the same price. It needs to be something very close. If we want that guy to move, it needs to be very, 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 very cheap. So it's not the same number we've got currently. It's not Huawei or Ericsson or Nokia network. It's not the same. It's not the same price. So the private network, which is going to be very small private network, need to be very not expensive and very cheap. And so what we do and why we're moving, okay, we are using open source technology, okay? And we are based on Open RAN because one of the price is due to the hardware and the equipment and the fact that we can update. So I'm not going to go into the detail of ORAN or the Open RAN, but it will definitely decrease the price. You can have a great number of radio access units. You will be able to plug it on your system. and it would be very easy. Also, another thing important is the open source. As you're going to see, we have use cases quite complex. And so we need to have a huge number of people working on these use cases in order to make it happen. So this is why we base on open source. And we have chosen open interface. I know that some of you in Linux Foundation, they use other system, but we're moving for open interface because it's complete solution which integrate 5G and RAN, and I will explain you later. So just open interface, that's few numbers, so that's the number. Currently there's something like 100 people who participate to open interface, and there's new guys coming every day. So for instance, NVIDIA just come, and NVIDIA, in order to make acceleration, so in order to have CUDU for ORAN quite efficient. So there is some actor which work on this Open RAN community, and they're going to work with an open interface in order to make it open interface efficient and affordable. So this is the Open RAN. So just a few words, open interface. I'm not going to focus and give you all the roadmap of open interface because there's plenty of things. We had a meeting last week in San Diego with Irfan, so all the roadmap are available there. So if you want to check, there is you will have all the documentation. So this meeting has been held into Qualcomm premises, and it's there. I'm going to focus on few points, which is one, Open RAN, geolocalization, and TSN. Okay, that will be the main use cases that we want to cover. Come from our customer. So very simply, okay, what kind of architecture? Okay, with private network, we go from small to large, but not too big. Okay, it's not going to be a huge coverage. It's not going to be AT&T. It's not going to be Orange or this kind of thing. It's usually a small part. So for instance, we are working with Airbus. Airbus, it's few factories in Europe, but small area, and they just want to put it together. So they need to have a private network, a private cloud network, where they're going to do some part of the management, so part of the 5G core in a private network, and they will do some private cloud edge within the factory. But we will have also example where everything is in one thing, so it's really compact. You know, the core, the RAN, everything will be put in the same place. So in order to make it very not expensible. So one interest of open interface is this ORAN flavor. Okay, there is a roadmap within open interface on ORAN. They will do the split, the totally disaggregated architecture. So the CUs, the DUs, the RU will be split in everything. The split will be 7.2. So and it's there, and there's also some acceleration that will be done for the DU level. So the different layers, the layer 2 and 3 will be done by open interface, and the layer 1 will be by acceleration. So this is a huge ADN of open interface, and here there's AMD, you've got NVIDIA, you've got Philips, NXP. There's plenty of people working on this acceleration and this optimization of Open RAN. So this is one use cases. This one is very important in order to decrease the price. The other one is the geolocalization. So currently, there is a need in this industry 4.0 to have some geolocalization system. They already got some solution. They already can use ultra wideband, for instance, or Bluetooth. This technology are available. But here, what we want to propose and what is going to happen with open interface is that means that everything will be in one solution. So the open interface will integrate this geolocalization. So Here in that example, we've got a pilot with Stellantis. So it's a car manufacturer. And so it's so here it's very simple use cases. It's a screwdriver. So the guy needs to perform a certain number of action on a car. So something like 40 or 50 with a screwdriver. And so we need to count it and to know that all these actions are done around the car. Okay. So this is one use case that has been that will be done on Stellantis. We've got the same thing with Airbus. There is also some geofencing use cases. So the worker will have a kind of a 5G tag. So with the 5G tag, you're moving, and if you're coming, and if you are very close to the robot, suddenly the robot starts to slow, and if you are something like 1 meter to the robot, it stops totally. Okay. So this is a kind of a process. So everything, all this geolocalization will be integrated, is currently integrated within the OpenAI interface. It will allow to have an accuracy of sub-meter on FR1 and 20 centimeters for FR2 frequency. So that's a good result. So this is one example. And the last one, which is maybe the most complex one, which is the TSN use cases. So the TSN is a time-sensitive network information. So the purpose here is to have IP packet with time information, and you're going to deliver this IP packet in less than 20 milliseconds, 40 milliseconds, and you can ensure this quality of services, and you can ensure that this IP packet will go to that robot in less than 20 milliseconds. And this, on the top of TSN, in Industry 4.0, they have defined a specification which called Profinet or Profibus, which use the TSN and which is used for automation. Okay, so this TSN support within 5G will allow to support many use cases, Industry 4.0 use cases, and in a wireless manner. Currently, TSN, it's wire everywhere. So here, the 5G network will act as a kind of TSN proxy. So it should be totally transparent for this Profinet and Profibus application, which are already deployed, which already exist in this industry. So, but it will be a wireless thing. So, and for instance, with Airbus, they say that if we manage to do it, they've got something like 10,000 devices that need to be connected using this TSN network. So it's a huge functionality, and as you can see, this one implies the RAN and also the core and also the UE part. So you need to have a complete solution, and so this is the kind of thing we're working with on OAE in order to support TSN. So in order to do all this activity, we've got a group in OpenAI interface, which is a group for private network. So really the purpose of this group is really to bring OpenAI interface at the level for private network. So if there is use cases, if there's new use cases that need to be done. So here, within that group, we collect the different requirements, technical requirements to make use cases. We are going to organize the roadmap and the development in order to have a good understanding, and not, for instance, geolocalization. There's plenty of people working on geolocalization, and there is different development everywhere. So we put everybody together and to have an open source community working on different use cases for this private 5G network functionality. And so it's coordinate, support, and as soon as we're going to be ready, we're going to push this this profile within the 5G super blueprint in LNF, in order to that would be the next step. And that's all. So if you want to join the group, do not hesitate. There's plenty of activity working on OpenAI interface on that subject. Thank you. Yeah.
So the use case, the ORAN use case that you mentioned, right? That's ORAN compliant. Right?
Yeah.
And if you consider that use case with the ORAN is software community, the project that is there in transformation, are they similar or how different these two, the ORAN use case and the ORAN C? There's an ORAN software community project in Linux Foundation.
Yeah.
So that also builds like software based on the ORAN specification.
Yeah. Here really the purpose is to have open interface which supports ORAN specification. So there will be interoperability. Interoperability testing with LNF, so that's possible. But here it will be really open interface ORAN, and we should have some interoperability possibility with this specification. But
the ORAN is C.
Yeah.
I don't think that they are similar, or they can.
The specification will be exactly the same. So the interoperability, and it's based on ORAN.
Both are based on the same specification, so there should be interoperability.
There should be interoperability, yeah.
And that use case is fully supported by open interface.
Yes, and there is it's a collaborative project. So it's a European project. There's some German and some French and some different countries from Europe working on this ORAN interoperability. So there will be different implementation and different interoperability tests between all this part, the CU, the EU, and blah, blah. So really the purpose is to use open interface as a kind of foundation in order to do some interoperability tests for ORAN, and make it happen. So all the actors will be able to test their ORAN implementation within this environment.
Yeah. It includes all the non-real-time RIC and real-time controllers.
Yeah, there is some non-real-time and real-time RIC in open interface. There is a project named Mosaic, which is an implementation of. Yeah.
Open source or?
This one is open source, yeah. And you can see there is, and you can get the. This is that one. I don't know which one. Okay. If you go there, there's a roadmap of this non-real-time and real-time RIC. So this one will be also integrated. So.